Good morning, everyone. Cautionary tale this morning. If you can have a look, this is this Cosimo Nordmende chassis, radio chassis that I've been working on, and I've done a video or two on it. And I'm still struggling with it, or have been. The problem has been in that, if you want to look at this little fella here, I decided I wanted to add a magnetic phono preamp, and that I accomplished in this shielded box with two nice so-called gold-plated connectors. It needs a power supply. I base it on this, which is Booz Hound passive RIAA compensated magnetic phono preamp circuit. I've built a number of these and they work relatively well. They require about 24 volts positive DC to run, which is fine, and in some cases I've been able to steal the voltage from the filament circuit on a standard radio chassis, double it, and get close to what I need to make it run. Alright, now we come to the problem that I've had here. What I built, this little fella, is a module for Bluetooth that I bought a number of. Pardon me, get the wiring out of the way. And very inexpensively. Works quite well. But unfortunately for tube circuits, it doesn't seem to provide enough of a drive to get a full volume on it. So then the complication comes. But first, in trying to hook Bluetooth up to a doubled or rectified filament voltage, I was encountering hum problems that I couldn't seem to solve. So what I did is, in this case, I found this little 14 volt AC transformer kicking around in my parts box. And so I used that. So what I have here is a voltage doubled power supply. So that gives me about 32 volts. And I have a 24 volt regulator, which will power the Booz Hound preamp. And it also, I have used in the past this circuit, which I got online, which is a single stage, or in the case of stereo, two of this particular circuit, based on a 2N2222 bipolar transistor. And I've built a number of them, and they work fine. I like them. They give the boost that the Bluetooth needs, or any other circuit that needs, and everything was fine until now. So this is the remains of the circuit here. So I built it, I hooked it up, everything works fine, the radio's fine, the AM's fine, the magnetic phono preamp is fine, but the Bluetooth wouldn't work. Now the Bluetooth was working because the little blue LED in there was flashing, and I could get a signal coming out of it. But what happened is something in this wasn't functioning. So in typical fashion, I got a little dismayed, and then I walked away from it. Now this was part of this, okay? And I'll explain what happened. So one night when I couldn't sleep, I thought, oh, I've probably hooked up the transistors backwards. And when I come down the next day, I was eager to try. And the problem with building these on perf boards is that once you've soldered them in, it's a devil to get them out without destroying the board and everything else. So what I did is I cut the transistors out, which ended up by ruining the transistors, but who cares? There's what I cut out. No legs on it at all. But I've got like maybe 100 of these things, and so I didn't care. So I soldered in the new ones, the right orientation around, and lo and behold, I had a signal, but I had almost no gain. It wasn't doing much better, if anything, than just the Bluetooth device feeding through, bypassing it. And I puzzled and puzzled and puzzled over it, and I could not figure out what was going wrong. Everything looked like it was hooked up fine. So then I got a little peeved with it, and I come up with what I thought was a better idea. And I would take this booze hound and take this part of the circuit, in other words, one stage gain of FET, F-E-T, amplification, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 resistors. The FET, which I have a lot of, and an input coupling capacitor and an output coupling capacitor. And of course the additional filtering system that goes with it. So this time I thought I'd be smart, and I breadboarded it. And that's when I discovered my problem. For some reason, when I started assembling the parts that I needed, I started checking the resistors. And lo and behold, what I had 47 ohm resistors, and I had like 100 of them, and they were wildly off, and that demands a further explanation. What I did with a friend of mine way back in about 1970, that shows you how old I am, we decided that for our own purposes, he would buy for us packages of every common value of quarter watt and half watt resistors. And he paid his kids to get them all parceled up in the appropriate values and the appropriate numbers so that we each had half. So over the years, I've used the half watt ones, but I didn't have much use for the quarter watt ones until recently. And now, let me take another little tour around the shop, and you can see my parts bins, and I'm sorry I can't get this wider shot, but I have, for a small shop, a rather comprehensive selection of parts. Up here is all my bins for quarter watts, all right, from 0 to 50 up to 1 meg plus. Down here, stopping there, is all my half watt. And then I can move over to this, and I have my 1s, 2s, and, whoops, where are we? 3 watt resistors in those two sets there. That's 10. And then you move down to here, and I have 5, 10s, and 20 watts, whatever will fit in there. So that's comprehensive. Up here I have low voltage, no, that's low voltage, these ones here. I have low voltage capacitors, 0.5s, 0.082 for microfarads, and high voltage like 600, 450 to 600 there. Down here I have transistors in a hodgepodge of things, thyristors, hardware here, diodes, Zener, cable mounts, IC sockets, all sorts of stuff. Up here I have small value picofarad type capacitors, safety capacitors, and some trim pots, power ICs, resistors, switches, diali, a fair bit in there. Various ICs including solid state regulators, LM388, 387, you can see them there. There's 7805, 12, and 15, and the 79, the negative ones in there. And a lot of empty ones still. I'll fill them. Potentiometers, H1. So anyhow, blah. It's rather complete. Oh, I should go over here. I've got more stuff over here. Mostly phono parts and plugs and jacks, belts, cabinet screws, various connectors there, phono cartridges, and then I get into my stock of small electrolytic capacitors in there. So as you can see, it's rather complete. Now we'll get into my problem children. Okay, and I'll pull this out. I've already thrown out a whole bunch. Now, let me get my glasses on so I can see. And you can see that there's a mix of styles. And the original ones that I bought are these carbon, where are you? There you are. Carbon resistors. And who knew that they, over the years, even though they haven't been used in circuit, they drift off value horrendously. The 47 ohm resistors that I mentioned earlier, none of them were anywhere close to being within 10% tolerance of the 47 ohms. Some were so wildly off as to be over 100 ohms. So then the penny dropped. And as you can see in this circuit, this has a few of these carbon resistors. So my cautionary tale is, don't always trust your component stock, especially if you've had them for a while, like me for 50 years. It cost me a lot of headache with this, and I was being driven crazy. So what I did, I think we'll get back to this, is I used my Dremel and I severed the board. This board was part of this board. And I cut it off with the Dremel. Then I built this on a scrap, and if you turn it over, I put a ground bus bar on both, and then soldered the both sections of the ground together, and now it is really well put together. And glory hallelujah, it works, and it works fine, thank you very much. So what I'll do is I'll put this on pause, and then I'll go get my cell phone, and I'll fire it up and show you how it works. Okay? Okay, I'm back. And you can see the blue LED on that little module. That means it's connected to my cell phone. Pardon the jiggly camera. But I'll start things up. And you can see that it produces good sound. This is all from the Bluetooth. Okay? Now, unfortunately, because of restrictions, I can't play much. So I'll just stop that. And, oh, okay, pardon me. I have installed a selector switch because in typical German radio fashion, there's one push button for phono and for tape deck, and that's all there is, all on the same function. So what I did was disconnect the input from the DIN phono connectors at the back, run it out to this switch, okay, and so now I have the choice of, once you push that so-called phono button, you can select between the Bluetooth and the phono, and I will be putting a set of auxiliary jacks for whatever use anybody wants, and that will go on the side of the cabinet. I think, as I mentioned before, this came out of a console where the wood was perished, and I'm going to take the pull-out drawer, pardon the jiggly camera again, but this is the pull-out drawer that would tilt out from the top of the front of the cabinet. And I've saved that. The chassis will slide in with the glass there. I have to take this out to the woodworking shop and make a square back to it and some kind of a safety back on there with ventilation. And that'll be ready to go. I'll put some feet on it. And the speakers have been saved, salvaged, reconed the woofers, and I've made cabinets for them. And they're about to have a finish applied to them, and then it'll be ready to be used for whatever. Not sure what I'm going to do with it. I mean, I like doing these things. All right, I can show you that we have FM, such as it is.
Yeah. So you studied and like more traditional theater.
Okay. Choice of FM stations up here is not too bad, but I think I've mentioned before that almost exclusively all the German stereos really were made for urban situations. They all use this one 6AQ8 as a mixer oscillator front end, and for urban situations it's fine. Out here we've got two very strong local stations, both CBC, and they're like 2 kilometers away, and they blast through, and they're very loud. And when I go to other stations, they're much more muted, and you've got to turn the volume up, and there doesn't seem to be an awful lot of AGC action for the FM, although they did employ a rather interesting situation. I wonder if I can show that here. I've got the schematic out, and I'm not sure that I can explain it properly, but I'll do my best. The FM and AM, IF, is this tube, the EF89, and let me zoom, pardon my jiggly. What they've done is they've taken a signal from the detector, and as far as I can see, that's a DC, and they, instead of grounding the, it's not the screen, the suppressor grid, pardon me, of this, usually the suppressor grid is either internally or externally connected to the cathode. In this case, it isn't. It has a signal which should control the gain of this stage to some degree, and I guess it does to some degree, but in the situations I've found with all the ones I've serviced, it could do with a lot more. If you're looking at AM AGC, it's a lot better designed, but that, I guess, is problematical when you get to the FM front end, which is this 6AQ8 here. There's no attempt to put AGC in. In fact, on this model, I believe there's no AFC either. There's no AFC button. So, at any rate. So, short video, cautionary tale. Possibly not a bad idea if you have any kind of a tester. And this is the one I use most commonly. How accurate it is, I don't know. But it serves the purpose I need. I plug in whatever device. It identifies the lead orientation for transistors, which is handy, and it also gives you a relatively accurate indication of the value. And like I said, the shock was when I plugged in these 47 ohm resistors that they came up with 75, 82, 103. It was horrible. So I've learned my lesson, and I've ordered a complete package of 10 units each of every common value of the quarter-watt resistor, and they're coming in from the Orient, of course, and I will go through all my resistor base for the quarter watts and root out these carbon composition resistors and throw them as far as I can, save myself the aggravation. So that's it for this morning. Thank you for watching, and have a nice day.